Last week we looked at the triangle inequality theorem and we looked at possible lengths for the third side of a triangle when the two sides that were given were of lengths 3 and 6. And I thought I'd do a little demo here with Geogebra to take a look at this. So I'm going to start by putting a point at the origin, and then I'm going to put another point 6 units away from the origin. So segment AB here, if we connect those 2 points, that segment would be the one side of our triangle. The next thing I'm going to do is construct a circle with a center and a radius. My center is going to be at A and my radius is going to be 3. And now I'm going to attach a point to this circle. And now I'm going to draw a segment from point C to point A. And since this is the radius of the circle, we know that that length is 3. And now I'm going to connect segments C and B to get our other side of the triangle and B with A. So segment BA is a length of 6, segment AC has a length of 3, and we can see right now in this picture that the segment from C to B has a length of 5.3. So if you take a look here, we can see that if I drag on my circle, oops, undo that. If I drag on point C, let me get my pointer here. If I drag on point C, we can see how segment AC is staying at 3 and segment AB is staying at 6. And we can see that segment BC can get very, very tiny, almost 3, really close to 3. And there it looks like it's actually equal to 3, but of course we can see it's still a little bit above the axis. But in terms of precision for GeoGebra, it's essentially 3. And then we can see that as I move this over and make this an obtuse triangle, that we could have this segment go all the way, the length of BC here, our third side of our triangle, go all the way to 9. And then, of course, going back around the circle, it goes back down to 3. So our original two sides of our triangle are 3 and 6, and our third side must be between 3 and 9, the difference of the two numbers and the sum of the two numbers.